Good morning, everyone. Good morning from Berlin. My name is Nikita, and today I'm going to talk a bit about the upcoming PHP 8.0 release. So, first things first, let me briefly introduce myself. So, I am one of the PHP core developers. I've been working on PHP for a while now already, mostly in my time as a student, in my free time. And since the start of last year, a nice company called JetBrains has picked me up and now essentially sponsors me to continue working on PHP full-time. You probably heard of them because they are the producers of the PHP Storm IDE that probably a lot of you are using already. So with that out of the way, we can jump into the topic of PHP 8. Let me start with saying when we actually expect PHP 8 to arrive, which is the end of this year. So PHP has a very nice, predictable release cycle. We do one patch release every 4 weeks and one minor version every year. End of last year was PHP 7.4. And this year is going to be PHP 8.0. And to say it very clearly, because there seems to be some confusion on this point, there is not going to be a PHP 7.5 release between those two. The PHP 8.0 release cycle is going to start pretty soon. So in 2 weeks we have the first alpha release. And at the end of July is feature freeze, when all the final features inside PHP 8 are going to be decided. And the final release, as already said, is going to be end of the year in December. And with that, let's jump into the new features. And the first one that probably already has gotten quite a bit of coverage is the just-in-time compiler. Normally, when PHP executes code, it does so by compiling the PHP code into virtual instructions which run on a virtual machine. What the JIT compiler does is to instead compile PHP code into actual CPU instructions, so into x86 machine code, and run this machine code directly on the CPU, in the hope that this is going to improve performance. In practice, the way this works out is that the code that sees the largest performance benefit is the more mathematical type of code, not your average web application code. And I put this in as a big disclaimer, because going from PHP 5 to PHP 7 we had this huge and free performance improvement, oftentimes by 2 or 3 times. And going from PHP 7 to PHP 8 you're not going to see this kind of improvement. So with the JIT compiler maybe you'll get 5 or 10%, but you should not expect any miracles. So the JIT compiler is part of opcache. So if you want to try it, you have to enable the opcache extension, set opcache JIT on, and specify JIT buffer size. But this is really all I want to say on the topic, because the JIT is actually quite interesting from a technical perspective, but covering that in any amount of detail will be like a completely separate talk. And I don't want to do that, so I'm going to switch over right to the more user visible language and standard library features in PHP 8. The first of which is attributes. As you see in this example code, PHP already has an existing pattern of PHP doc annotations, where you embed some metadata into doc comments, and this data gets parsed out and then processed in some way. This has the very unfortunate property that suddenly your code comments affect program behavior, which is something comments usually should very much not do. As such, PHP 8 makes attributes a first-class feature, which allows you to annotate classes, properties, functions, and so on, with attributes which are, as you see here, written in angled brackets and consist of a class name and an optional set of constructor arguments. The actual classes used in these attributes are just completely ordinary PHP classes. The only special thing about them is that they have at the top a PHP attribute, which signifies that this class is indeed intended to be used as an attribute. Conversely, if you just write the attributes on a class, they are not going to do anything. They are not even going to be validated in any way. To do something with the attributes, you have to go through reflection. So you call reflection class get attributes, and then you get a list where you can get the attribute name, the attribute arguments, and finally you can create an instance of the attribute object. And this final call, this new instance call, this is where the actual validation of the attribute happens, and this is where the construction of the attribute object happens. Finally, there are a couple of limitations on the current attribute system relative to the existing PHP doc annotations. The first one is that PHP does not have support for named parameters, in general and also in attributes in particular. So if you have like doctrine, column of type string, and unique is true, then we would translate this into the attribute system by using a kind of options array pattern. So instead of passing it as simple arguments, you pass it in as an array of named options. The second limitation is that we have no nested attributes. So this example from Symfony, we have these nested assert not blank and assert length annotations, and what these essentially mean is just creating a nested object, and this is not allowed because attribute arguments are required to be constant expressions, and right now in PHP constant expressions cannot use the new operator. In both of these cases, these are current technical limitations and we might be lifting them in the future, but now they exist. Well, now actually finally, what do we use attributes for? I think I've already given a couple of examples. We have them existing users of annotations in Doctrine, Symfony, but we also may want to use attributes for certain internal things. So we might want to expose PHP itself might want to expose a deprecated attribute for deprecating functions, classes, constants, and so on. And we might want to provide the ability to control certain compiler or runtime behavior, like a JIT or no-JIT attribute. But both of these are just ideas, they do not exist yet. Moving on from attributes, the next larger category of changes are type system improvements. So each PHP version tends to, increase the capability of our type system, and at some point maybe it will finally be expressive enough to say everything we want to say with it. But we're not there yet. So union types should be familiar from PHP doc already. And we already have two specific union types in PHP. Those are the nullable type union, so it's type or null, and the iterable type, which is traversable or array. Union types are just the general version of this feature. In this example, we have a number class, and we say number is an integer or float. And we can convert this PHP doc format into native type annotations, with the usual advantages that this is now actually type checked, that you can access it through reflection, and that it integrates well with the existing strict type, weak type system. Union types also have two special types that can be used in unions. One is the false pseudo-type, which is very, very common in PHP's own standard library. In this example, we have stirpos, which either returns a position in a string or false if it's not found. From a modern perspective, we would say that instead of returning false, this should be returning null. Then you would have nullable type. But unfortunately, that's not the reality we're dealing with. We have a huge amount of functions in PHP that already use the something or false pattern. And to support these, we also support false as a union type. But of course, we do also support null as a union type. So here array key first returns integer or string key, or null if the array is empty. And yeah, this is just an additional syntax for nullable types. The existing question mark type syntax is still allowed, and it's just a shorthand for this type or null syntax now. One of the trickier semantic things about union types is their interaction with weak typing. So if you do not say strict types equals 1. The problem is that, well, if your type, if the value you're passing, the type of the value you're passing, if it's part of the union, then you don't have a problem. But if it's not a part of the union and it's a scalar, you have to think about, well, which of the union types do you actually cast it to? And we solve this by specifying an order of preference. So we say that if you have a scalar, then we'll try to cast it to an integer or float first, then to a string, and then to a boolean. So numbers, strings, booleans. To give an example, here we have a function which is not meaningful at all, but it accepts an integer, float, or boolean. And then we pass first integer or floats to it, which is the simple case because those just get passed through. Then we pass a numeric string to it, in which case the result will be either an integer or a float, depending on what kind of string it is. And finally, we pass in a non-numeric string, in which case the result will be a boolean true or boolean false. And I would say that this case where the cast is to boolean is pretty weird and quite likely unexpected, but it's in line with current PHP behavior. Finally, if you pass in something completely absurd, like an array, an object, or a resource, then you get a type error. And if you do what I would recommend, if you use strict types, then all of these type conversion cases go away, and the function only accepts integers, floats, and booleans, and you do not have to worry about how strings are going to be converted. Next to the union type, the other type system addition we have is the mixed type. And the mixed type is essentially equivalent to, it means that any value is acceptable, and as such it is essentially equivalent to specifying no type at all. The reason why we still want to distinguish a mixed type is that it allows you to differentiate between, is this type missing because it's an old method that hasn't been typed yet, or does this argument actually accept, like intentionally accept, any possible value? And in this context, a question that, well, usually comes up is why would a function accept any possible value? Don't you have to like refactor it to reduce inputs or something like that? And no, there are plenty of functions that really do accept any kind of value. I think two examples would be the var dump function, dumps anything, and the serialize function, which also serializes anything. Maybe the more common case is the case where you use mixed to work around the lack of generics in PHP. So here is the signature of the array reduce function written out in terms of type parameters. So we have the array key type, the array value type, and the return type of the reduction callback. But PHP does not support generics, so we cannot write the signature like this. Instead, the next best approximation we can make is to take the union over all possible type parameters and look at what the result would be. And the result is this, so that the initial argument is mixed, can be anything, and the return type is mixed, can be anything. Like a particular call will likely set these to a specific type, but if you look at all calls, then mixed is simply the best we can do. Now, one more detail is how mixed interacts with inheritance. For arguments, it's very simple, because their mixed and no type really is the same. So you can freely have a parent method with mixed and child method without type, and that's legal, and the other way around is legal as well. The more interesting case are return types, because in that case, not specifying a type is not the same as mixed. It's the same as mixed or void. And because of that, the code shown here is not legal, because the parent method is mixed, while the child method is mixed or void. So the universe of the return type increases, and that's generally not permitted. Now, apart from union types and the mixed type, we have one more type system addition, which is the static type. Static type is to be seen in conjunction with the existing self and parent types. And now the static type. So this example, we have a name constructor which returns new static. And this static is to be understood in the sense of late static binding. So for those not familiar, this means that if you extend this class, so you have a child class, and you call the method on the child class, then new static will create an instance of the child class on which the method was called, not of the parent class on which the method was declared. And it's exactly the same semantics for the return type. The return type, the static return type, tells you that this method is going to return the class on which it was called, not the class on which it was declared. So next to name parameters, two more common cases where this occurs is the wither pattern, which you're likely familiar with from PSR request response objects or other immutable objects. Because here we clone this and return that, and this is always an instance of static. Very similarly, if you have fluent methods, which also always return this is an instance of static. So once again, static will be the right return type to use here. Now that much for type system improvements. The next language level improvement is the introduction of Constructor Promotion, which is, like I would say, not a very meaningful name. What it does is to reduce the amount of boilerplate you need for value objects. So here we have a class point with 3 coordinates, and to declare it you need to first you have to first declare the properties, then you have to declare the constructor arguments, and finally you have to assign the constructor arguments to the properties, which means that you repeat all the property names 4 times and the property types 2 times. In this example, it's still pretty fine because you have these very nice and short property names, but in reality, this tends to blow up a little bit more. So Constructor Promotion provides a shorthand syntax. You can include the visibility modifier in the constructor before the constructor arguments, in which case PHP will automatically generate property declaration and assign the constructor arguments to the properties. Oh, okay, and one very minor feature is that you can now also leave a trailing comma at the end of a parameter list, which is useful for these kind of very long signatures that you have to break across multiple lines. That much for language features. Now I'm going to switch over to some library additions, and the most important one is obviously the addition of the string contains function, which is really just a very thin wrapper around strpos. And to complement it, we also have string starts with and string ends with. So personally, I think that these are great additions because these are some of the most common string operations, and it's handy to have like a readable way to express them. But I do find it somewhat interesting that PHP is nearly 25 years old at this point, and now is the time when we actually introduce these helper functions. But okay, better late than never. One question that comes up in this context quite commonly is, why don't we have something like mb str contains? The reason is that these three functions are already perfectly safe to use with UTF-8 strings. So we do not need an MB variant. They are not safe to use with some other encodings, like, I don't know, UTF-16. But in my opinion, if you don't use UTF-8, then that is really your problem. One more library addition is the addition of weak maps. In PHP 7.4 we already added weak references, but if I'm being entirely honest, weak references are not super useful by themselves. The actual weak structure you usually want to have are weak maps. And what the weak map does is just a map where you have objects as keys and some arbitrary value. But the important part is that the map does not keep the object alive. So if the object is destroyed, here in the last line, then it will be automatically removed from the map. And this is quite useful for various caching structures. So if you have some kind of expensive calculation and you want to avoid redoing it and instead have a map from object to the calculation result, and you store this in the normal map, then you have the problem that if the object is no longer used anywhere else, it will still be in the map. And even though no one will ever be able to use that cache entry again, it will still keep taking up memory. The weak map solves exactly that problem. So if the object is no longer referenced anywhere else, anywhere externally, then it will be automatically dropped from the weak map. Okay, this much for feature additions. I should be clear that I'm really just, scratching the surface here. There are many more additions in PHP 8, but I only have limited time, so I only covered the ones that I thought are most important or interesting. And instead, I'm going to spend some time talking about the backwards-incompatible changes. So one class of backwards-incompatible changes is that everything that has been deprecated in PHP 7.4, 7.3, and older has been removed in PHP 8. The good news here is that if your code is deprecation clean on PHP 7.4, then you do not have anything to worry about these changes. The problem is that not all of the backwards incompatible changes in PHP 8 have gone through the deprecation process previously, or even could have gone through it. And these are the changes I really want to discuss. The first one is the migration from resources to objects. So this is a general long-term goal we have. We want to we want to basically remove the resource type from PHP and convert all existing resources to objects, because objects are type safe and they have much better internal integration because they support things like cyclic garbage collection. This is also the reason why we do not support the resource type in PHP. Because first we consider it somewhat useless because it does not allow you to distinguish whether like this resource is a file resource on one hand or an FTP resource or a curl resource. And if we introduce the resource type, we would have problems doing this kind of resource to object migration because it would break more code. I should clarify that when I say we migrate to objects, that we are migrating to opaque objects. So the objects are only used as a representation mechanism. They do not actually expose any object-oriented APIs. We might want to add those later on, but for now, the object is just encapsulated storage, and you still interact with it through the usual procedural APIs. So these are some of the extensions that already have been converted in PHP 8, and there are quite a few more still in the works, like curl, for example. The primary concern as far as backwards compatibility is concerned is that if you have code like this, where image create from PNG is now going to return a GD image object, which is obviously not a resource, this code is now always going to throw. And to avoid that, you should instead be checking for the error return value of the function. Because this code is going to work perfectly fine both on PHP 7 and on PHP 8. The second larger category of changes are warning to error promotions, to error exception promotions. In particular, we are converting warnings to either type errors or value errors in most cases. And this is not for all warnings, but for a very specific class of warnings. Namely, those warnings that indicate a programming error. So warnings or error conditions where it does not make sense to somehow handle an error locally. You actually need to fix your code. To give some examples, here we have the strlen function, and if you pass an array to strlen, then in PHP 7.4, this is going to throw a warning and return null, which is very unfortunate because it means the strlen return value is actually not an integer, it's integer or null. But for all practical purposes, you're never going to encounter that null return value. So in PHP 8, instead, this throws a type error, and this also allows us to say that the return value of the function is always an integer. A similar example, we have the arrayFill function, and the second argument is the number of elements. If you pass negative number of elements, then currently you get a warning and a false return value. So we are in the same situation, that the return type is array or false, but if your code is correct, you will never ever encounter the false return value. So instead, this throws a value error in PHP 8, and the return type is just array. One more example. Here we have the fopen function, and we're trying to open a file that doesn't exist. Currently in PHP 7.4, this throws a warning and returns false. And in PHP 8, in PHP 8, this is not changing. The reason is that fopen failing to open a file is not a programmer error. It's a totally expected environment condition. And it is expected that existing code does explicitly check for the return value of fopen, so check if it's false, and in that case handles it appropriately. So these kind of error conditions are not being converted into exceptions. Okay, now to talk about the last topic, which really belongs in the feature section, but is also strongly related to many of the backwards compatibility breaks I've been talking about. It's the addition of PHP stub files. So these files specify the signature of internal functions, methods, and we use these files to generate the C code that PHP uses to register functions internally. For example, here we have the stub for the array search function, and this is the corresponding generated arcinfo code. And you can imagine that writing out this arcinfo structure by hand is not particularly convenient, which is why we use this kind of code generation approach. These stubs are useful primarily for two things from the end user perspective. The first one is that the information is exposed to reflection. So you can use reflection function get return type, reflection parameter get type, and reflection parameter get default value to get this information programmatically. And actually, reflection parameter get default value is something that simply did not work at all for internal functions prior to PHP 8. The second thing, the stubs effect, is the inheritance behavior of methods. So if you extend an internal class like datetime, then we have this kind of stub. So we have that the datetime add method accepts a date interval argument, which means that now you can extend datetime, and your add method can also specify a date interval argument. Previously, if you try to specify the interval argument, you would get an inheritance error because you try to narrow the argument type from everything to only date interval. Now it's possible to write like this, but not required. You can still leave off the type. This is also the reason why the stub in this case does not specify a real return type. Because if we did specify a real return type, we would actually force extending classes to also specify it. And we don't do that for backwards compatibility reasons. Okay, and that's it from the side of both features and BC breaks. I want to close this with some ways to try out PHP 8. The simplest one is to go to eval.org, where you can test PHP code snippets across multiple versions. And if you go to the branches tab, then you can also execute it on PHP 8, which is PHP master here. Then probably the most useful thing you can do if you are an open source library maintainer is to run nightly, which is currently PHP 8, on CI, and, well, probably put it under allow failures, but at least like take a look, I don't know, does it crash or something? Are there any obvious bugs, or how compatible is your code with it? And to do that, you will generally have to specify the ignore platform requirements option in Composer, because at this point in time, most library code will not be officially compatible with PHP 8 yet. Finally, there are Docker containers, which include PHP 8, for example, this one. And with that, I'm done. So thanks a lot for listening to me. And also thanks to everyone who has worked on the PHP 8 release and has made this possible.
Okay, hello everyone again. You just heard a talk by Nikita Popov, and we have Nikita Popov and Viktor Zinchenko online right now, and Viktor will ask questions to Nikita. You may start.
Okay, so yeah, we have several questions, and probably the first one is about JIT. So if it is not improving performance.
I think the sound cut off a bit just now, but I still think I got the gist. So the JIT does improve performance for certain use cases. In particular, if you, I don't know, do something crazy like do machine learning in PHP, then the JIT will definitely help you. And of course, there is also hope that the performance for general web application is going to improve with further work. In particular, the just-in-time compiler started out as a method JIT, which means that we compile whole methods. And recently, Dimitri has been working on, or mostly finished work on, converting it into a tracing JIT, which means that we collect traces for the code execution, especially around loops, especially around loops. And actually record which types are used and insert guards so that the compiled JIT code only contains the most optimized path, and everything else is going to fall back to the interpreter. And this is like a JIT approach that was mostly, I think, made famous by LuaJIT, which is probably like the JIT compiler ever. And there is some hope that this is going to work out better for like your average web app. But right now, still unclear. So.
Okay. Yeah. Thank you. And then several questions about RFC process. So if something was paused, can it be changed? And another question, and how about if the feature that was paused was already implemented? So how it goes there?
Yeah, so the main limit there is that once we have implemented and released something, then of course it can no longer change, because that would be a backwards compatibility break. At least usually we cannot change it anymore. But if it hasn't been released yet, then it's still possible to do a change either through general agreement or another RFC. And I think what people might have in mind here is the new attribute syntax, which for many people is not particularly popular. So the double angle brackets or the shift operators. And right now we have an RFC that changes that to a double @ sign at the start. So we can't use a single @ because that conflicts with the error suppression operator. But we can use two @s, and there is a proposal in discussion right now. And if the vote on that one passes, then there is no problem with changing the syntax prior to the PHP 8 release.
Okay. And another one question about RFC. Can we somehow see a diagram or a roadmap for the planning features and so something like this?
Well, PHP doesn't really have a roadmap in the sense that people have an agreed upon vision. It's more individual contributors who work on what they want to work on, more or less, where each contributor tends to have their own idea where PHP should be going over time, which might be some of the reason for PHP's not super consistent design, but okay. I think the best place to look is either the PHP wiki, which has a list of RFCs, including those under discussion, and those are the ones that are more likely to actually come to pass. And of course the PHP internals mailing list, but there isn't really a convenient place to just see at the glance what might be coming up. Not really.
Oh, okay. And the next question is about types. So how do you think union types and mixed type, will it suggest users that is okay to mix the types altogether?
Yeah, that was a common discussion point. Personally, I would hope not, of course. One of the main motivations for having these is, for me at least, being able to type already existing APIs, especially in our own standard library. We have many union types, and I think there is benefit in typing them even with those unions, rather than just leaving the signatures untyped and in that case completely unsafe. So you get more information if something is a string or array than if it's just without a type at all. And of course, I think that having a union type is not fundamentally wrong. It always depends on the use case. So you shouldn't overload signatures too much, but I think it's in many cases reasonable to accept for a method either a string or an array of strings, for example. I don't think there is anything bad about that.
Okay.
But of course,
Yeah,
actual usage will show.
Yeah. So next question about also types. So what about an omit feature, or maybe better to say except? So we are able to pass to the method, for example, instance of a class, but not the next class. So for example, like instance of anything, but not resource. It's probably like a feature request, or is this possible, or could be a case?
So this is first time I'm hearing about it, and I honestly haven't thought about it before, and I'm not really sure what you would use it for. So I'm not really seeing the use case where you accept everything except one type.
Well, yeah, me too. So, well, for this moment, I don't know what this question about is. Maybe Vladimir can add something later about this. So, and the next thing is about moving from previous versions to PHP 8. Are there any tools or for compatibility checker purposes? So, do you know something about this?
At present, probably not yet, but usually for each PHP release, there are checkers. For automatic migration, there is the Rector tool, which, well, does code transformations itself, but there is also some kind of PHP compatibility library that will presumably get updated for PHP 8 as well. So tooling probably doesn't exist now, but it should exist by the time the release comes around. But we, from the internals perspective, don't really deal with that. This is all user efforts.
Okay. And yeah, next question is about return types. So what do you think about returning from fopen null instead false? So it will be more clear for users.
I don't like that much because it's a backwards compatibility break, and a pretty bad one at that. So anyone using fopen correctly right now is going to check for a false return value. And if we change that to null, then everyone has to change their code. And if they have to support multiple PHP versions, then they have to check for both false and null. And I'm not sure what we really win from that. I mean, I personally do prefer if functions return null on failure, but I don't think it makes a huge difference if they return false. So if we want to change anything in that area, I would rather go from returning false to throwing an exception. But that's an even larger change. And my personal preference there would be to introduce this not by changing the existing fopen function, but by introducing a new object-oriented file interface. And that new interface could then also start throwing exceptions right from the start.
Okay. And the next question is probably inspired by your speech about migrating to objects from resources. How to participate in this process?
Write me a mail. So I can point you to a couple of existing pull requests that do it. It's not a particularly hard process. So it's relatively mechanical what you have to do. And one can just copy one of the existing pull requests, more or less. Okay. But I don't have a ready-made reference right now.
Okay. Also, we have several questions about new features, or maybe new possible features, or new feature requests. It's about having generics and event loop natively in PHP. What do you think about this?
So I was totally sure that those two questions would come. For generics, we have the big problem that the PHP type system is validated at runtime. So unlike pretty much all other languages, we don't check types at compile time, but we check them at runtime. And that both has a performance overhead and has a lot of implementation complexity. So I started at the start of the year an experiment to implement generics in PHP for some very simple cases, just to estimate the amount of work that would be. And the amount of work is going to be really large. So we have a lot of places where classes are referenced, and basically all of those places would have to migrate to take generics into account. And by many, I mean something like 1,500 places in the code base. So this is a lot of effort, and the effort will likely make PHP somewhat slower even for people who don't use generics. Which is why I am kind of skeptical at this point in time that we are going to get this feature sometime soon. I would be more happy to somehow do generics the way they are available in Psalm or PHP Stan, so where it's only static analysis, because that's both much easier to implement and more performant. But it's not really clear how we can go from our current state, where we have these runtime checked types, to this static analysis approach. So there is no clear migration path, at least I haven't heard of one. So in the near future, I don't really expect that. And for the second question, the event loop, or the tightly related to that, async await syntax. So I'm really not an expert on that part. I haven't done any event loop work in that area. There are a couple of userland implementations like React and AMPHP, which of course have the disadvantage that they don't have any tight language integration. And there was work on an async extension at some point, which implemented the native event loop. Unfortunately, the work on that one just stopped. In fact, the repository got deleted for still unknown reasons. And I think since that time, there hasn't been any real progress in this area. So I don't think anyone is actively working on getting that into PHP right now. And it's kind of not my personal area.
Okay. Another question is about AST extension. How it's about enabling it by default, so it may help with some special cases, for example, static analysis tools and so on.
So we can do that. The AST extension is at this point relatively old and stable. I'm not quite sure how actually useful it would be. I know that the fan static analysis tool uses it, but I think it's the only one. So everything else, like Psalm and PHP Stan, they use PHP Parser, which is implemented in PHP and has a couple of advantages, in particular that it supports multiple PHP versions and has generally more precise information about locations. So while the AST is useful for us internally, I'm not really sure if or how useful it's going to be to expose it to users. We can do it, but there hasn't been a lot of interest in this recently, but maybe if someone has good reasons for that.
Okay, and the question, next question would be probably the last in this session. Do you think developers would have a lot of problems to migrate from PHP 7.4 to 8 version?
Good question. So recently Symfony did the, well, not migration, but at least the support for PHP 8. And from what I've seen, it wasn't terrible. So Symfony is always a bit of a special case because they have lots of magic going on internally. So lots of hacks that are very tightly tied to the engine. And at least the observer impression I got is that it wasn't a terrible upgrade. But of course, that always depends on your code base. So if you are already deprecation clean on PHP 7.4, you stand a much better chance than, well, deprecation clean and warning free and notice free. If your code is currently throwing 10,000 notices per request, and maybe some of those notices have become exceptions in PHP 8, then you will get much bigger problems.
Mm-hmm. I see. So yeah, thank you for your answers. I think we covered the most of the questions, probably all of them. So yeah, I think that is a good discussion.
Okay, thank you very much once again. First of all, Nikita, thank you very much for your amazing talk, and I really appreciate that you joined us this conference. It means a lot to us. And Victor, thank you very much for being today moderator, let's say like this.